I'm talking about some wisdom about artificial intelligence, the role and responsibility of humans, and where and why AI succeeds and fails. Thank you for listening and watching. Why do I want to talk about wisdom about AI? Well, two reasons mainly. AI is highly fashionable, so people are interested in it and seek to apply it and study it, whether it's appropriate or not. The second is that AI is misunderstood. It's seen as just a tool that can solve all our problems. And many people are saying, well, I need no humans. AI eventually will not need any humans. We can bypass the human. I disagree with both. So the aims of this lecture, which I'm giving to the University of Salford Business School, is to suggest some wisdom about humans in AI and about application types of especially machine learning AI by introducing Dooyeweerd's aspects. Dooyeweerd was a Dutch philosopher, and I have used his aspects in many of my activities and researches over the last 30 years. I was involved in AI in the 1980s in industry, and I learned a lot of valuable lessons. So then I'll go on to the role and responsibility of humans and where AI succeeds and fails. So aspects of everyday experience. Dooyeweerd studied meaning, whereas most philosophers ignored meaning, and he discovered 15 aspects. There might be more, might be less, but he found 15 aspects that are mutually irreducible. Each aspect is a sphere of meaning and law, and it has a kernel meaning and a kernel goodness. So, for example, for the biotic meaning, kernel is to do with the integrity of the organism, life, alive in an environment, and it is good to be healthy, not so good to be ill. Socially is to do with people together, not just as individuals but as groups, relationships, and it's good to be friendly, not so good to be at enmity or isolated. And they are irreducibly distinct. The laws of the physical aspect cannot be reduced to those of the kinematic, nor vice versa. The laws of life cannot be reduced to physics. The laws of sociality cannot be reduced to language, and so on. And laws of ethics cannot be reduced to law. Just to introduce you to these aspects, let's have a look at the aspects of this talk. What is happening as I am talking, as I am lecturing? Well, the central or core aspect of a talk is communicating. So the lingual aspect is, if you like, the qualifying aspect, or the one that leads this talking, lecturing. However, there is an aspect of the number of people. By the way, these aspects can indicate things that we might study or describe about a talk. So the number of people, where we are spread out in the classroom or wherever we're talking. There is movement of hands as I gesture, movement of air, there's movement of content as we move through the talk. There's a physical aspect, which is to do with, in this case, sound wave transfer. So this talk happens and is enabled because sounds come from my mouth, vibrations go through the air and land on your ears, and that if there was no physical aspect, That would not be possible. Is anyone here dead? The biotic aspect is needed for a talk. We need to be alive to engage in a talk. We need to be hearing and seeing, whether it's talking, writing, or whatever. We need also to distinguish words from sounds. Just listen. What do you hear? You hear other things besides my words. But until I ask you to listen, you are probably focusing on my words and not just the sounds. That's the analytic aspect coming in. The opposite, the good that the analytic aspect brings in is conceptualizing, clarifying, and so on. The formative aspect is human formative power, to do with forming, planning, achieving goals, means. It's also to do with techniques and technology. Let's go to the later aspects and communicating. So, for example, I treat you as people. I've been to lectures where often in philosophy, where the speaker has just read from a piece of paper. That is providing information, communicating, but not treating the hearers as people, just as information sinks. And it's not so good usually. There's an economic aspect of a talk, limited time. There is an aesthetic aspect, which is not just art, but it's to do with interest, leisure, enjoyment. And Dooyeweerd argued that at the root of these is harmony. Harmony as in a symphony, as in an orchestra playing, where all the bits come together and form a whole that is greater than the sum of the parts. Holism. There is a juridical aspect in a talk, that I should be talking about what you're expecting me to talk about. So in this case, AI. If I go off and talk about spring flowers, not related to AI, that would excuse me, that would be inappropriate. The juridical aspect is also justice to others, justice content, justice to hearers, justice to speakers, and so on. And a talk goes well if we do justice to each other. Ethical goes beyond what is due, justice, appropriateness. It's generosity. It's self-giving love. That's its core, self-giving love. And so I tend in my talks to give a little bit more than what I've just been asked to do, as long as I don't take up too much time on it. Pistic aspect, from the Greek word pistis, pistin, meaning vision. What we fundamentally believe, what is most important to us, what we are committed to, our aspirations, our expectations, our beliefs, our commitments. Think of it as when you sat on your chair. Did you test it first? No, you just assumed it was going to take your weight. That's a tiny little bit of pistic functioning. And it goes right up to what we're willing to give our lives for, a religious belief and things like that. That's big pistic functioning. So there we are. It's given you an idea of the aspects, all aspects of everyday life. They give us meaningful issues to understand, and they're also quality criteria. These are all have a kind of normative, a different differentiator between good and bad. Now, we're going to use aspects in this talk to think about AI. And there's two things: activity or behaviour, and then there's the content of the activity. So take, for example, this lecture. This is a lecture about AI and its use in organisations. Lecture is the activity, and it's meaningful in the lingual aspect. It's about three things: AI, which is a technology, so meaningful in the formative aspect, but also something that people worship today, people aspire to. So it's pistic aspect. Use, is formative again. We use something for some purpose, and organisations are social. So we're going to look at two parts of this activity. Lecture is going to be, one is going to be looking at using aspects to look at the activity of humans, and the other is the content of the knowledge base of the AI. Activity, by the way, just bear in mind that when we function in any aspect, when we speak, when we socialise, when we create, when we distinguish, there are repercussions. I'll probably mix these together because of the limited time of this talk, but get the idea that we can differentiate between functioning and repercussions. So, my experience of AI. I joined ICI in the 1970s, a big chemical company, and then I went to University of Salford with the RICS for a research and application project. In ICI, I built 4 expert systems, or was involved in 4 expert systems. Expert systems are a type of AI. The corrosion system was to predict stress corrosion cracking, a very unpredictable, very dangerous thing in chemical plants. Suddenly a vessel would explode. And it's not just by corrosion, it's stress as well, a combination of them. Then I helped a world-class corrosion engineer express his knowledge. I expressed his knowledge in an expert system. He liked the idea, so he then built his own system for advising his team on insulation properties. Then I was shifted to a totally different field of farming, advising farmers, building an expert system to advise farmers on the use of fungicides on winter wheat. And then I was involved in a business sector analysis system, which would ask the users, usually managers of business sectors, about their business, and would come up with some kind of solution. But it would first ask them, well, what do you think? And it would say, I disagree with you, or I agree with you. What do you want to do? Take your answer, your view, my computer view, or do you want to probe and explore the difference between us? And of course, that was the main thing. It was to help users. It does not just give us advice, but to explore differences, explore had they overlooked anything. Then I went to the University of Salford with the RICS and built a system called LC, to advise quantity surveyors on the budget they should set before even an architect has started design. I learned a lot of lessons during this. First of all, I learned how to elicit knowledge. And I also learned that it's a human exercise relating to experts as humans, not just as knowledge sources. I learned about tacit knowledge, rare exceptions. Tacit knowledge is knowledge that you have but cannot tell. For example, knowledge of riding a bicycle or playing tennis. But there's also social tacit knowledge of how to get on with people, or skills that you learned 30 years ago and forgotten about, you just have them. Then there's knowledge of exceptions, exceptional cases that are to the general rule of elicited knowledge. For example, I found 2 experts I interviewed in corrosion disagreed. They gave me different knowledge, and when I probed and asked why, always a good question to find tacit knowledge or exceptions, it turned out that one works at temperatures above 300 degrees Celsius, the other temperatures below, and at 300 degrees Celsius chemistry changes. Once I knew this, I was able to put this into the knowledge base, but it was missing knowledge until then. How many other exceptions might we have? that are missing from our knowledge or our AI systems. And finally, finally of this group, multiple aspects. When John Hines built his insulation system, it was mainly about temperatures and physics and chemistry and all these things. But there was one question. How likely is it that feet, ladders, etc. might contact the insulation? What he was referring to was that workers in chemical plant would lean a ladder against a pipe, then go up and stand on the pipe to reach something higher. You have to take that into account in the real world of deciding which insulation to put in. That was a formative aspect of reaching, not just a physical chemical aspect. It was also social as well. So I learned, here, hang on a minute, in real life expert systems you need to take multiple aspects into account, ones that you don't even expect. Another thing was that experts are able to build their own expert system. And there was roles of expert systems. These were to give advice. This one was to refine knowledge. And so was this one, the surveying advisor. There was also a contract writer. I was involved in building a system to write contracts, construction contracts. And again, this one was interesting, because when it was used not by those who didn't have the knowledge, but by those who did. And what it would do, it would have a bunch of people around the screen discussing together the answers they give, the parties in the contract, for example. So it was a social as well. Another thing I learned was that AI has to be embedded in other technology. This thing, I was involved in embedding it in early networking and in multimedia. Then there was responsibility and courage and broader vision. Now this is an interesting one. You see, I was a member of the Green Party. I was an environmentalist, and I was being asked to build an advisor for fungicides. Chemical farming. I knew that some farmers didn't want to maximise their chemical input. So I asked the agronomist, well, what would you advise in that case? And they said, oh, no, nobody, everyone wants to maximise their output. And so they'll maximise their input. But I said, well, I've come across farmers who do want to reduce their chemical input. What would you advise? Oh, in that case, skip the second spray and use something else. And they had the knowledge, but it wasn't going to come out in the normal run of events. I needed I had a broader vision than just building an expert system to the contract I'd been given. And I took responsibility. Partly because I'm a believing Christian, partly because I'm an environmentalist, and I could see something more, and I took the courage. Now you see, knowledge engineers and AI developers have a responsibility beyond just producing what they've asked to be produced, or what their own ego or whatever wants them to produce. We've got a responsibility to the future because of packaging up knowledge. So these things I learnt during my stay at ICI and the RACS and the research project. And it's interesting because let's have a look at which aspects they're meaningful in. So physical for these two and a bit of formative for reaching up pipes. Farming was, of course, biotic, or economic and spatial in that disease could spread. Business analysis was analytical, economic, juridical. Opistic was to do with their vision for their sectors. That's to do with the laws and so on. Surveying was ELSI. Notice I've given them names now: Core, LAG, ELSI and INCA. Was the analytical aspect mainly, but some quantitative, but also lingual, conversation around the terminal. And the contract writing was lingual, of course, writing, but also juridical for contract and social. So there were all these different aspects, different ones with different aspects. Let's have a look at aspects of content. It's not actually later. I'm going to quickly look at these now and then come back to these. You see, Elsie, these are the aspects, and the things I was working in were relevant over several aspects. Inca was juridical, Inca was lingual, Elsie was lingual and quantitative, core and lag were physical, farming was biotic, business analysis was analytical, and so was Elsie. Business was also a little bit economic. And so these are kind of the main aspects. I've left out some secondary ones. Now, if you're on YouTube, pause and think, what other applications of AI do you know about, and in which aspects are they important? We'll come back to some later, but for the well, here is the later. These ones are the ones that have been in the media, like driverless cars, kinematic, chess and X-ray analysis, spatial. We'll come back to these later. Molecule design, medical, of course, is biotic. Voice extraction is sensory. Art and music creation is aesthetic. Fraud detection, and large language models are, of course, lingual. We'll come back to that later. AI system. Let's now have a look at let's get our terms right, our thinking right. An AI system, an AI app, the software if you like, is a knowledge base with an engine to run it and a user interface through which a user communicates. The knowledge base is developed by an AI developer, and in the 1980s when I was involved, we elicited knowledge from domain experts and wrote it into the knowledge base. But today, knowledge bases are trained with pattern detection and other things from masses of training data. But the AI developer is still involved, still needs to use their wisdom to select data to be training data, clean it up, get rid of outliers, decide what to do with outliers and so on. And they also have to tell the trainer which parameters are meaningful. There is the algorithm designer that designs a trainer and the engine, a software. And finally, is what I call the deployer, if you like, the senior management or the person that decides to put money to invest in AI in a company or personally. Now, of course, these could be sometimes the same people. The deployer can be the developer for a personal system and the user. But there are, if you like, 4 different roles. There are 2 different types of AI. One is what I call KE-AI, knowledge elicitation AI, and the other is machine learning AI, learning by looking for patterns. And I'll use these terms, KE-AI and ML-AI, through the talk. Now, KE-AI is knowledge elicited from experts and then represented in the knowledge base. ML-AI is knowledge inferred, detecting patterns in masses of data. Now the thing is, here the KB is knowledge base is trained, here the knowledge base is written. This is labour intensive and this is energy intensive. Huge climate change emissions. Microsoft's carbon footprint went up 30% when they got into AI, because training of 200 billion pieces of data is a huge computer load. huge energy consumption. We have to be responsible. In a time when we need to reduce our climate change emissions, the world, with its fashionability of AI, is going to all the way going galloping towards AI, is doing almost the opposite of what we need. Just think about it. Just a little bit about machine learning. I'm not going to go into the technology much, but there are 3 types of learning and 3 stages in learning. The 3 types of learning is supervised, unsupervised, and reinforcement. Stages are doing the bulk of pattern detection, and then SFT, supervised. Supervised fine-tuning, and then reinforcement learning with human guidance. So, the AI developer must tell all the 3 types and stages what to look for. In supervised learning, the developer gives labels, but in unsupervised, the AI looks for its own labels. So you might think there's no human input there, but yes, even in unsupervised learning, the AI developer needs to tell what's meaningful. For example, customer segmentation was given as an example of unsupervised learning, but the developer needs to tell the trainer what is a customer and all the various things pertaining to customers, all the various aspects. Okay, there's 4 humans here, 4 different responsibilities. The AI developer must make sure that the knowledge base is correct and complete, but also good, i.e. ethical. The algorithm designer must make sure that the software is fully correct and reliable. The user has a responsibility to use the AI system, AI application, for good and not harm, and wisely and frugally. If AI generates huge climate change emissions, then you could say the less we use AI, the better. So use AI for important things, not frivolous things. Just for fun. Don't use AI for fun. That's what I try to do. I'm not actually telling you what to do. It's your decision and your responsibility. But I try to use AI as little as possible, and so as not to use AI in Googling. I go to UDM14. I think there are other things that don't use AI. The deployer has a responsibility for thinking long term and indirect. For example, don't invest in AI that is going to do a lot of harm, especially a lot of climate change emissions or bringing health problems, and is responsible for the overall project. The problem is, most of the discourse about AI in academia as well as business and industry and especially government is about the benefits and opportunities of AI. We must also discuss the harm, and aspects can help us with this. Harm and benefits can be direct and immediate, such as the driverless car killed a cyclist. Come back to that later. Or indirect and long term, such as climate change emissions. So aspects of using AI. These are just some examples of, if you're a user, you're functioning in all these aspects, and you'll have to take these into account. I said the use is formative aspect, trying to achieve something. The purpose of use is its formative aspect. What plans are there for use? Quantitative, how much we use AI. Spatial, the geographic locations. Kinematic, do our plans change? Do our ideas change, move as we use AI? Well, climate change emissions is one of the physical repercussions of using AI. Health impact on us and others. Is AI going to mislead us as we get health advice, mental health impact and so on? Is it going to make us lazy, selfish? Analytic aspect of using AI is when to use AI and when not to. And also, if you're going to put in, let's say you chat GPT, what information do you put in that's relevant to, as opposed to irrelevant? That's an analytical functioning of the user. Is understanding AI output, which is our lingual functioning, not misunderstanding it, and also ensuring that we express our queries to ChatGPT or Copilot properly. Working with others is a social aspect of using AI. Does the AI waste money? Or does it waste our time? Does it waste our resources? Or does it save them? Embedding in life and work. That's the aesthetic aspect, one of the aesthetic aspects, as well as enjoying using it, the fun of using AI, but embedding it in life and work rather than being fragmented. Doing justice to all, including the future, is a juridical aspect of using AI. Ethical. Are we using AI selfishly for selfish aims? Is our motivation for good? And pistic is actually that we have a motivation for using AI. We have expectations of it, aspirations of it. We believe or not believe it, and so on. These are all examples of all the aspects of using AI. Notice that some are blue and some are light green. The blue ones are impact, repercussions. The light green ones are our functioning. Now we could have impact in these and we could have a functioning of these. It's not time to go into a lot of detail. This could be a whole lecture, just this one slide. So I'm just showing that there's a mixture that we need to consider. Aspects of developing AI. It's mostly functioning of the developer I'll talk about. So the main aspects of developing AI are formative, of development, planning and training, coping with errors, and the lingual, understanding the meaning of each parameter that we need to put in, and of course a dialogue with others in the project. Okay, quantitative is the amount of training data needed. Kinematic, during developing AI, we'll change the knowledge base, we'll develop it, and we'll even, from time to time, change our sources of knowledge. We'll move things around, move it forward. Power consumption in training, especially climate change emissions. Health of AI developers, mental and emotional health of the AI developers are important. Distinguishing relevant parameters from irrelevant is the analytical aspect of developing AI. By the way, this light green here is not, there's no difference here between repercussions and functioning. It's mainly functioning. Working with others and frugal use of data, frugal use of energy are social and economic functioning of developing. Making sure the AI app hangs together, is in harmony, and embedding it in its context, thinking about embedding, putting in right knowledge, and thinking about justice to all, to the users. The attitude of developer. Are they selfish or generous? And the mindset, what's the expectations of the AI system? And so on. So, again, all aspects. I couldn't think of a spatial one, but probably spatially spread out team or something. is aspects of developing AI. Aspects of deploying AI, I'll leave you to discuss this. You can pause the YouTube here and think about it, and then carry on. So, part 4, why AI succeeds or fails. This is to do with content. So, you see, we've been talking about the behaviour of all the humans. But now we're talking about the content of the knowledge base. There are 4 types of knowledge that are involved in when we use AI. There's knowledge. The user has specific knowledge of the situation or context of use. There is knowledge of the application type, so like X-ray analysis or something, which is put in by the AI developer. But then there's knowledge of the kind of application. So, for example, pattern recognition of JPEGs and screens and so on, and that's put into the engine and the trainer. And then the deployer has knowledge of the state of the world now and in the future about investing in AI. So all these 4 types of knowledge come together, but we're going to focus mainly on knowledge of the application, and aspects can help us. So application of the application, why especially think about why AI fails. There's erroneous knowledge, the hallucinations of ChatGPT, because on the internet there's a load of rubbish as well as good stuff, and it doesn't know the difference. It's trained its knowledge base, its massive knowledge base of how to respond to humans, on the rubbish as well as the good stuff. There's missing knowledge. So, for example, the driverless car did not have knowledge of cyclists pushing the bicycles. So it did not recognise that as a human being and ran them over. But then there's whole missing aspects that the developer, AI developer, just overlooks. The elephants in the room. Things that are taken for granted so much. So, for example, the missing aspects in the lagging system. What humans want to achieve was missing until John Hind put it in. And there's probably other things as well. This is why most AI applications are multi-aspectual, and that causes a problem especially with ML AI. But aspects, separating out the aspects, can help us with each, because in the knowledge base is encoded the laws and the rationality of each relevant aspect, so that it runs and reasons appropriately for the type of application. So, what are the laws like? The early aspects have the simplest laws, the later most complex. The early aspects their laws are best known, the later aspects least known. And the later aspects, their laws are not determinative, whereas the first 4 aspects of the laws are largely determinative. Like 5 and 4 will always make 9. Whereas if you put 2 sentences together, or there's, let's say, a question and an answer, give a question, and there are lots of different ways of answering it. The lingual aspect. There's non-determinative. But also, to make things worse, there's interactive dependency. The laws and rationality, the laws of later aspects depend on those of earlier. So, for example, the physical aspect depends on the laws of the kinematic aspect, spatial aspect, and quantitative aspect. 3. the laws of the lingual aspect depend on the laws of the formative, the analytical, sensory, biotic, physical, kinematic, spatial, and quantitative. So, if you like, if you need to develop a knowledge base with the laws of the lingual aspect, you have to have all this stuff as well. And you'll find that some others as well, but I won't go into that. That's extra. So the later the main aspect of the knowledge base we want to produce, the more difficult it's going to be to encapsulate all the laws that are needed. And for the final aspect, it's going to be almost impossible, because very little is known about the faith or pistic aspect. We're at the beginning of understanding it. Religions have some awareness and knowledge of this, and we could look at those, but be careful. This is why I believe that AI is there's never going to be fully general AI. And AI is not going to just fully take over from us. So let's have a few applications. Chess. It's mainly a spatial problem. Positions. There's laws of chess moves that need to be put in, laws about numbers of pieces, and there's a bit of a goal of checkmate. So the laws of checkmate and so on. So the key in these screens is the purple is the main aspect, green is needing some of the laws of an aspect, and white is very simple version of laws. So you don't need the whole of the formative aspect to play in a chess AI system. Analyzing X-rays, again, is to do with spatial. It's mainly to do with shapes rather than positions. But it needs some biotic knowledge of organs and sensory knowledge of colours, and maybe a few others. Driverless cars is mainly a kinematic problem, but it needs laws of spatial aspect for the road layout, laws of physical aspect for friction, power and force, or sensory aspect for recognition, analytical aspect in order to distinguish humans, biotic to prevent injury, a little bit of the goal. Formative is to reach a destination, very small road signs, just needs to detect road signs, doesn't need to read every single advert, and understand. So that's limited. Fuel efficiency, yeah, that's limited, and the laws of the road are also a very limited set of juridical laws. But there's a lot to put in to driverless cars, plus perhaps others. Now look at large language models and ChatGPT. Its main aspect is language. It also adds a social database, ChatGPT does. Its goal is it needs some knowledge of formative law, the formative aspect in achieving goals and so on. It needs a lot of knowledge of the analytical aspect. It needs knowledge of the sensory aspect, or at least an analogy of it, an analogy of dimension. It needs, of course, knowledge of the quantitative aspect, because it holds its information as 12,000 parameters. Read the work, the paper that comes with this. Aesthetic aspect, it needs a little bit of this, and probably others. This, I think, gives a key to understanding why ChatGPT doesn't work as well as many had hoped, because its main aspect is one of the later ones. However, we don't need to be 100% correct. What I've said is you need all these laws to be 100% correct. But there are different roles of AI systems, and I learnt this in the early 80s. there are replacing humans and assisting humans. Replacing humans, of course, is things like robotics and decision making by AI. Assisting humans is things like training, so using the AI system to help train humans and demonstrating possibilities. There's also advice giving. And three things that I found during the 1980s: the checklist role, where the AI system or the AI app, it helps the user make sure they haven't forgotten anything. When Elsie got into actual use, it got into commercial use, by the way, and we found that the surveyors would use it, even though they had the knowledge, to just check they had not forgotten anything. I found that a knowledge base could, if you like, is a recording of good knowledge in a systematic form, and so it could be good to help communicate knowledge between people. And then knowledge refinement, where human knowledge was refined by the use of the AI system, or even during development knowledge was refined. John Hines, I would ask him a question. I would say, why? And he said, well, actually, I don't know. So he went away and did an experiment, or he thought about it and refined his own knowledge as an expert. But usually knowledge refinement, especially in the business analysis advisor and in contract writing, was to refine the user's knowledge. So there are these different roles. For these roles, the knowledge must be complete and correct. So, if we're going to replace humans, unless, of course, it doesn't matter. So, use AI only in the early aspects, where the laws are simple, determinative, and well known. Here, knowledge can be slightly incomplete. You can have something that will help train humans so far, and then they finish off their training with humans, and also demonstrations of what might be possible. You don't need the full knowledge. So, for example, the business analysis advisor did not need all the knowledge of human beings, all the knowledge about business sectors. It was really just depending on the human knowledge. But these four, the knowledge must be explainable. Advice: do you just take the advice, or do you ask, well, why do you give me that advice? It needs to explain. Checklist: you need to know what the full knowledge is in order to know whether you've missed anything. Communication: it's a record, it's an explicit record, understandable, explainable version of the knowledge, and knowledge refinement, so as you can ask why, and you can explore the difference between the knowledge base and the human knowledge. This has implications for the technology. Machine learning AI is great for this. Knowledge elicitation AI is probably, it can be done, but not so good, especially because in things like the sensory knowledge, it's pre-analytical and therefore pre-lingual, and it's often tacit knowledge that cannot be expressed. There's muscular tacit knowledge in playing tennis, but some tacit knowledge can be probed and produce these things of later aspects. Tacit knowledge of the lingual, or how we speak, and so on, and so on. Knowledge can be slightly incomplete, so both technologies are okay here. But for explainability, it's really only knowledge elicitation that can produce explainability. Pure machine learning, although lots of research is being dedicated to explainability or transparency, it's I don't believe it ever will be, because of the fundamentals of machine learning is to reduce all kinds of aspects of knowledge into one type, which is either numeric spatial in the case of ChatGPT, or an analog of neural nets, neurons in neural nets, and it just loses knowledge and combines it. It's really like having lots and lots of drops of water and just pouring them all in together. So, roles of AI systems. It's important to understand these roles, and that's where I've come to. So let's go back to the lessons I learned and review this whole talk. Wisdom, I've suggested. Well, remember, all these are human activity. Remember the human activity of all four humans. Remember knowledge elicitation AI and learn from it. Most people think of this as old-fashioned and no longer relevant, but I believe there are all these lessons that I learnt from it that need to be learned, possibly relearned, by machine learning people. Machine learning is not good for every application. So those who extrapolate and say, well, we've been successful in X-ray analysis and so on, therefore we're going to take over the world, I think are fundamentally wrong. Dooyeweerd aspects can help with all of these. And finally, remember climate change and all these other things that people tend to forget. Remember our responsibility, have courage, and adopt a broader vision. So, thank you for listening, watching. There's accompanying notes with links and sources. You can get more, and I want to thank my old Amiga computer and its wonderful software for producing all this.